Hello everyone, here Juan Gea from Bone Studio, and today it's another tutorial day. So what are we going to look today? Okay, now we saw in an earlier video the Fracture Modifier branch. You can get the latest version of the Fracture Modifier branch following our how to build Blender video or tutorial where you will be able to build your own build of the Fracture Modifier. Just changing from, instead of using the MantaFlow branch, you just have to use the Fracture Modifier branch. That's it. So it's pretty interesting that the Fracture Modifier branch is giving us a lot of new features, and one of those features is a new mode in the Remesher modifier. This new mode is the Metaball mode, and in this mode we can remesh, or we can mesh particles or use vertices, and we are going to review the particles part. So how can we use this? This is amazing, this is great, because now we can use SPH particles that are in Blender since ages, and now we can mesh those particles and actually use those particles in production. We used to have Cube Surfer, but the latest version of the Remesher is faster than Cube Surfer. And plus, this is not an add-on, it's part of the Blender Fracture Modifier itself. So this is great because this is going to evolve with the Blender itself. And it supports motion blur, something that is also great to have the motion blur support. So let's go to review this. In the initial part, in the initial picture of the video, you saw in the splash screen of the video, you saw this scene rendered with all the materials and etc. I have this scene in a low version for the viewport because it takes some seconds to build the mesh at high resolution. But as you can see, we can play the animation and you can see the particles here. If we disable the remesher, you can see the particle simulation. We have Suzanne, and then Suzanne falls. That's it. Okay. And now my computer is frozen. Come back. Something with the cache of the particles, I think. Okay. So, and you see that this scene is pretty fast, but we are not going to use this scene because this scene takes a long time to cache the particles. We can see the particles here. Okay. Here we have the same scene. Okay, and this is just an SPH, a fluid particles, an SPH particle simulation. So it's nothing weird, nothing strange. We're going to create a new scene, and we are going to create something simple to illustrate this. So we have an icosphere that we are going to use as emitter. As always, apply scale for anything that you are going to use with some kind of physics simulation. Now we are going to simulate, to model. Okay, that's okay. And see, so we have this, that's okay. And now we are going to model some. Yeah, I'm doing so much subdivision because I'm lazy, not because any other reason. Now I select this and I dissolve them, and that's it. Okay, faces, extrude in the x-axis, add, and down in the z-axis. Okay, so we have some kind of wall to the particles to collide with, and these two walls are just so the fluid is not uncontrollable or uncontrolled. We can do that too if we want to open a bit. 5, no. Minus 5, no. Minus minus 3, okay. And gy minus 3, no, not minus. Gy 3, okay, that's it. Oh, and yeah, that's it. It's okay. Great. Now we have all we need to simulate something. We're going to put this here, and now we're going to enable the collision. We have the collision, particle damping at 0.7, random 0.1, for example, particle friction at 0.72, and random in this case 0.3, and a bit of a stiffness because I want the fluid to fall from the in the wall. So a bit of a stiffness for the collider. And now here the particle system is pretty simple. By the way, you may see the molecular add-on here, but we don't need the molecular add-on for any of this. So we're going to use the volume as emission. We are going to emit in jitter, it's okay, that's okay, and we are going to emit for okay, 25 frames and a fairly decent amount of particles. Yeah, that's okay. A bit more, maybe 35 frames and maybe double number of particles. Okay, now we need to give the particles some force, some speed. So zero velocity for the normal, so we don't have the particles trying to explode in the normal direction of the geometry, and we want in the positive x 1 speed. Let's try this. It's 10 as a speed now, and that's okay. It's not bad, not bad. Okay, now we enable the fluid physics. We use Berlet because if we see this message, the different integrators are ordered from the fastest to the most stable and accurate, and the most stable and accurate and not old is Berlet, and it's recommended for fluids, so we use Berlet, no other reason. Let's check what we have here, and everything is exploding, probably because the size is too big for this simulation. Okay, now maybe it's too low. A middle point, I think. That's okay. Now we have to fix the lifetime because we want the particles to have a lifetime at least of these 100 frames. I used 300 frames because I want to elongate the scene for the simulation. So here we have. Okay, and we have here the particles falling in the wall. Okay, now let's take some things like the subframes. The time step is we should leave this at this value if we are going to use 25 frames per second or 30 frames per second. It's more or less is the correct value. So it's how many seconds pass per frame. Okay, so let's give a bit of damp and drag. This is pretty important for any simulation, but especially for fluid simulation, so things don't go crazy. And we have to make the floor to collide. Okay, to collide also. Thickness, we do thickness here, and 0.7 and 0.3 in this case because I want this floor to damp more the particles. Particle friction 0.3, 0.7. That's more or less okay. It's you just can eyeball to decide what values to use here. It depends on the result, on the visual result that you want. So okay, we have this, and now I want to have a bit more detail in my simulation. So I'm going to enable, I can enable subframes, automatic subframes. That is, it modifies the subframe value depending on this threshold. Let's check. You can see that the simulation is slow when the particles are colliding, but it's much more stable also. Okay, let's check the result. Okay, it's a bit better, but we're going to disable it for now because I want something that I can control. Okay, now we have here the well, first of all, don't use Brownian because this gives a random movement, random force, a bit of erratic particle movement, and as it said here, and for the fluid we don't want random movement. Now we have here the fluid properties and advanced fluid properties, where the stiffness is okay. We can give the fluid a bit more of viscosity. So it is more like some kind of goo. We can even give it more. Okay, more or less, it's okay. Now, buoyancy. If you want a fluid that is kind of bowling of what was the word? I don't remember the word, but you want the particles to be going upwards after some time, you can give the fluid buoyancy. So, for example, if we give buoyancy, the particles go up, no matter if we have gravity or not. 0.5, and you can see some force. So now we don't want buoyancy. For the rest of things, we can use the repulsion distance is the distance that try to define the particles to be kept as a cluster, as a group. So if we increase this, we will give the simulation more stiffness, more aspect like a drop, so to speak. We can increase this 1.2 and we can check the results. And you can see here that the fluid is less spread. And if we reduce this value, okay, it's more like more separated. So we can, here we can see the full name here: repulsion factor, stiff viscosity, interaction radius. The interaction radius is interesting because this is when the particle is going to interact with the other particles. So a value of 1, we use the particle size to define when the particle is going to interact. So we can reduce this radius, so the particle starts interacting with other particles sooner, or we can increase this radius to force the particles to be a bit separated. For example, if I give 2 here, it's going to be the double of the size, so this will explode. Ah, no, it's not exploding. In fact, I think it works in the opposite way I said. No, because you see here that the particles are pretty separated. So if we give this 0.5, for example, the particles are more clustered, more together. In this case, radius of 3 was looking okay. Let's check. Ah, this. We can see that the radius is too big, so the particles are being like spreaded, but are pretty separated. This is okay for some kind of simulations. We may want this kind of effect without having to increase the number of particles in the simulation, but I like it. This is 2. We have some kind of goo with even with some holes in the fluid. Okay, that's great. Rest density is multiplier of the density, I think. I'm not sure what effect this has, but we can try it. So 0.5, it may explode, I don't know. Yeah, you see that it's been more spread. And if we go to 3, for example, it's keeping the particles together. I like this. Again, I'm trying to get some kind of goo here. Fast goo, but goo. Okay. And rest length. Again, I'm not sure what this does. I just eyeball the value. So, for example, we can try 0.5. They are more like clusters of particles. And we can increase this. There's not much difference. So we can leave this at 1. Okay, pretty important thing. We are going to save this as Remesher test 2, for example. So we can cast the simulation. And I want to cast the simulation because I don't want an overhead when I'm using the Remesher. Okay, that's it, and that's everything we need for the fluid simulation. It's just a simple fluid simulation. Now we can go here to display and to render. We don't want anything rendered, so we want points as display, and we want the velocity, and we want to adjust this 0.5, for example, or 10. No. Let's check. This is too much. This is too few. 3, 4. 4 is okay to show us, or 6. Show us the effect. Okay, let's get this to finish. And that's okay. So let's cast this. This is going to be cast very fast. And where is the cast? Here. Let's name this test. That's it. This cast. Okay, don't die. Right. And curve cast to bake. And that's it. We have our fluid simulation. And the old problem was that there was no way to mesh this fluid simulation, because this simulator can be great, can be used for many things, but we need to give these particles, we need to give them some kind of mesh. And this is where the Fracture Modifier build with the new Remesher mode comes to help. So we go here and we go to Remesh. This is just the old plain Remesher, nothing new. But if we go, let me save this in. If we go to Metaball and particles, we start to see some things. This is pretty big, so we are going to configure this. But we start to see some things. So if we use 0.3, for example. This is the size of the particles, so we can match the size of the particles. But if we match the size of the particles, when we are going to need a value for detail that is going to be too big. So just again eyeball it. So instead of 0.4, we're going to use 0.1, and this is for viewport, just for viewport. And we can see that it's pretty fast. We have our goo method, and we can go further on 0.05, and we get more details. So 0.05, it was the particle size, I think. We can go even lower, 0.025. Okay, 0.03, for example, and 0.025. We have some pretty neat detail here. We can go back. You see all this, and now we can apply smooth to smooth the mess that is being created. So we can apply 8 samples, and here we have a much better fluid mesh, and it's great. We have pretty big detail. We have a lot of drops. We have a lot of detail, so we can go further even. And this is too big. 8 and at 0.5 was great. Now, as we have this big detail, we can go a bit further even, 0.02. Okay, and now we have to configure the render size to 0.02 for the time being, but usually you use more lower value or higher value with less detail for the wire size. That is what we are going to see in the viewport. And for the render size, you use a pretty low value with high detail. In this case, it's okay. Smooth shading. Smooth shading. Okay, here we have. And now we go to the material. We are going to enable cycles, and we go to the materials, my good old principle VSDF. In GGX, I've been told that it's better in general, unless we need the multi-scatter option. So this is okay, and we're going to use, I don't know, some green goo. Let me check that this is in CPU, and let's render this to check. Oh, okay. We need an environment. So as always, I recommend to use, well, I recommend to be subscribed to the cloud. So texture, Blender cloud browser, some HDRI, that's landscape, for example. And I want what landscape? This is going to be pretty even. So we configure Amsterdam Central here, and we need more strength, 5. That's okay. Let me configure also color management. This is important, and one exposure. Okay, now let's go to configure the simplify options, just to make the render a bit faster. So 3 bounces, and now the sampling. Let's go to 100 samples for preview and to 300 samples for render. Timer 4, 1, that's okay. Light paths, that's okay. 0.01. And since we are going to use motion blur, we are going to enable inside performance, use spatial splits. And since I'm rendering with the CPU, I'm going to use a pretty low value. Bear in mind that this is not using the latest buildbot options, so we don't have, in system, we don't have the CPU plus GPU render options. So in this case, it's like the old version of all the render implementation in Cycles. So it's okay. And let's go back to the material. We want to enable subsurface because I can. Green subsurface and a bit darker. This is a radioactive. Let's going to mix this, and let's go to enable specularity. So we have some kind of specular go. Ooh. We can put light here just to check the subsurface options. Even maybe we can disable this. Let's use an RGB and black. Let's check what we have. This is cool. So if x, sorry, gx z, and let's configure this size to 1. So we have some area shadows and 200, and here we have our goo. We have goo, and let's create the camera, and now we can check this pretty cool motion blur, because the motion blur is not being rendered in the viewport preview. So we go to align view, and here we are. Go camera to view. And since we have enabled, well, since we now have enabled the motion blur, we just have to render this scene. Let's go to it. I think I have the region render enabled. I'm not sure. Bear in mind that the motion blur is slower to render. It's pretty slow, but this is a great option to have motion blur directly from render, because the result is going to be much better, especially if we are talking about pretty complex objects moving with curved trajectories and things like that. So the render is done, and it was pretty slow because it was a CPU, just CPU, 2 minutes, but here you can see the motion blur being applied. You can see everything. It's pretty cool to have this. If you want to exaggerate the motion blur more, you can go here to the motion blur options, and you can increase the shutter. So you can use 1 frame, 1 full frame, or you can change the shutter curve. You can do whatever you want. The motion blur options in Cycles are pretty neat. So good things, bad things. Good things about this Remesher. Well, the Remesher itself, it's awesome. It's great. And we can mesh alive particles, dead particles, and bored particles. We can define to mesh the particles by size, or with convert them to vertices to be used with other modifiers, etc. This is great. What is the difference between using SPH against using LBeam or using Metaflow? Well, the difference is abysmal. For starters, SPH are simple particles being simulated, so you are not constrained to a zone, to a domain. You can move the particles in the scene as you want. So this is a pretty great thing. The bad thing is that we don't have so much control about the particle look and the particle effect. So we can define just generate me some bubbles or generate me some foam. So this is great to fill a glass of water, for example, or to do some weird fluids like blood or like this goo. So it has its uses, and I think it's pretty neat. So I hope you liked the tutorial. If you liked it, please press the like button. This will help us to be more visible and to reach more people with the tutorials. And if you liked it, please subscribe to our channel. We will be releasing different tutorials in Spanish or English. You can follow us also in our Spanish live streaming that we do every 2 weeks. And that's it. See you in the next video, guys. Bye.